Hi, I'm Trisos, and I'll be talking about the key messages regarding solar radiation modification from the recently released IPCC Working Group 2 report. First, what is SRM in the IPCC report? SRM refers to proposals to increase the reflection of sunlight back to space to counteract human-caused global warming and some of its harmful impacts. The most commonly researched SRM proposal is introducing aerosols into the stratosphere to create a thin veil of particles to reflect incoming solar radiation back to space and offset global warming. So in what context does the IPCC Working Group 2 report consider solar radiation modification? It does this in the context of climate change risks. First, to define risk from the IPCC perspective, risk is the potential for adverse consequences to human or ecological systems. And these risks arise from the interaction of the physical climate hazard. You can see in the graph on the right-hand side of this slide, the physical climate hazard, which could be a drought or a flood or a heat wave, the systems that are exposed, such as urban areas or agricultural areas, and the vulnerability of those systems, such as their capacity to adapt to the hazard and the exposure. Importantly, in the sixth assessment report, the IPCC has updated this risk definition to also include the risk from adaptation and mitigation and other responses to climate change. And so it's clear that the severity of climate change risks is determined in part by how we respond to those risks as a society. And responses can reduce risk, but they can also increase risk or create new risks. For example, large-scale deployment of bioenergy crops or afforestation as a mitigation strategy can actually increase risks for water security, for food security, and for biodiversity. And within this context, the IPCC considered solar radiation modification in the Working Group 2 report as a climate change response that has the potential to reduce climate change risks, but also increase risk or introduce new risks. So first, to start with the climate hazards part of the risk. Most SRM research it's assessed has focused on climate hazards, and there's been much less on overall risk. The effects of SRM on climate hazards are highly dependent on the deployment scenarios, but in general, SRM approaches have potential to offset warming and ameliorate some climate hazards. However, there would be substantial residual climate change or overcompensating climate change at regional scales and at seasonal timescales, and this assessment is made with high confidence. SRM also does not address the root causes of climate change. So solar radiation modification would not stop carbon dioxide concentrations from increasing in the atmosphere, and it would not stop the resulting ocean acidification under scenarios with continued anthropogenic emissions. For this reason, there is high agreement in the research literature that for addressing climate change risks, SRM is at best a supplement to achieving sustained net zero or net negative carbon dioxide emissions levels globally. So what is the assessment saying about SRM's ability to address climate change risk? It's not dealing with the root causes of climate change, but can it reduce climate change risks? And in this context, there's much less research on SRM's potential to reduce risks from climate change compared to the focus purely on the physical climate hazards. There are large uncertainties and knowledge gaps associated with the potential of SRM to reduce climate change risks. And SRM approaches, if they were to be implemented, introduce a widespread range of new risks to people and ecosystems, and these are not well understood. In the case of specific sectors, there is low confidence in the potential risk reduction for crop yields from a deployment of SRM. For example, there may be benefits to crops at low latitudes in the tropics from reduced heat stress, but there could be negative impacts on crops at higher latitudes. There are many factors around UV and surface ozone and changes in rainfall that also affect crop growth other than heat, and these need much more research in an SRM deployment context. There's limited research on health, very limited research on health, especially infectious diseases that have high mortality and morbidity, and how a deployment of SRM may affect these health diseases. There's also the potential for SRM to reduce heat risk to corals, but risks from ocean acidification to ocean ecosystems would remain. There's large uncertainty in the response of terrestrial ecosystems to SRM, such as vegetation productivity and terrestrial productivity in rainforests. There's also large uncertainty in how productivity of ocean ecosystems would respond to SRM. And finally, there's high confidence in large negative impacts on the hydrological cycle and biodiversity from a sudden and sustained termination of SRM in either an intermediate or high emission scenarios. Moving now to SRM governance. The report assesses that there would be novel risks to international collaboration from an SRM deployment. And this is in the context where SRM could be deployed by a small group of nations or potentially even unilaterally, and countries can have very different preferences for optimal temperatures for SRM, for cooling. And so there could also be attempts to counter geoengineer. If one small club of countries was implementing SRM, other countries may want to counter those measures. As of now, there is no formal international governance agreement on SRM research, development, or possible deployment. And the governance objectives stated range from a prohibition to enabling research and potential deployment. Research to date has been done predominantly by a small number of experts in the global north, and unequal power relations exist where research could influence SRM governance and policy decisions, but much less research is being done by those countries that are often considered most vulnerable to climate change impacts in the global south. One example of this inequity in climate change research, for climate change research generally, this is not focused just on SRM, is that only around 4% of global climate change research funding has been spent on research focused on Africa since 1990. And most of this funding for climate change research on Africa actually went to institutions in the EU and the US. The consequence of this is low levels of adaptation research in many developing countries, as you can see in this map. And so the lesson to draw from this for SRM is clear, is that many of these countries regarded as the most vulnerable to climate change need to have a voice in SRM research and be able to participate in research to inform governance decisions. Finally, the report concludes that the co-evolution of SRM governance and research, with governance staying at least a step ahead of research, provides a chance to guard against potential risks and harms, and to ensure that SRM is considered only as part of a broader mitigation-centered portfolio of responses to climate change. You can find more details on this IPCC assessment of solar radiation management by looking at Chapter 16, specifically the cross-working group box on solar radiation modification at this link. Thank you very much.